Hi everyone. Today in this video I am going to solve some examples on indeterminate form of infinity by if infinity. So let's get started. Indeterminate forms. Indeterminate infinity by infinity form. So let us say there are two limits. Let limit f of x as x tends to 0 or as x tends to a is equal to infinity, and limit as x tends to a phi of x is also equal to infinity. Then limit f of x divided by phi of x, limit x tends to a f of x divided by phi of x is equal to, we can write by using L'Hospital's rule, that is limit x tends to a f dash x divided by phi dash x, or limit x tends to a f of x divided by phi of x is equal to limit x tends to a. You have to transpose denominator in numerator. We can write it as 1 divided by phi of x divided by transpose f of x in denominator. We can write it as 1 divided by f of x. So which is of the form, which is of the form 0 by 0. Then you can solve by using L'Hospital's rule. Sometimes directly you can use L'Hospital's rule, and sometimes you have to transpose denominator and numerator, denominator in numerator and numerator in denominator. Then it will be in the form of 1 divided by phi of x divided by 1 divided by f of x, which will be converted in the form of 0 by 0, and then you can use L'Hospital's rule to solve the example. L'Hospital rule means you have to differentiate numerator and denominator separately. Now examples: evaluate limit log sin x divided by cot x logarithm of sin x divided by cot x as x tends to 0, as x tends to 0. So in this case, if you write directly, if you substitute the value directly, it will be in the form of infinity by infinity, because if you substitute the value for this x is equal to 0 and this x is equal to 0, what is sine 0? Sine 0 is 0. Sine 0 is 0, and then log 0. What is the value for log 0? Log 0 value is minus infinity. Log 0 value is equal to minus infinity, and cot 0 is equal to infinity. So the given question is in the form of infinity by infinity form. In such cases, you can use L'Hospital's rule. What is L'Hospital's rule? You have to differentiate numerator and denominator separately. Limit x tends to 0. What is differentiation of log sin x? Differentiation of log sin x is 1 divided by sin x into differentiation of sin x is cos x divided by what is differentiation of denominator term. Differentiation of cot x is equal to minus cosec square x minus cosec square x. Then this is equal to the same term. We can also write it as limit x tends to 0. First I will write minus sign. This is cos x divided by sin x. Cos x divided by sin x, and this 1 divided by cosec square x. We can also write it as sin square x. We can write it as sin square x, where one of the sin x get cancels. Limit x tends to 0 minus sin x into cos x. And now if you put x is equal to 0, if you substitute is equal to 0 here, sin 0 is 0 into what is cos 0? Cos 0 is 1. So total on simplifying you will get 0, which is the required limit. Evaluate limit x tends to pi by 2. Limit x tends to pi by 2 logarithm of x minus pi by 2 divided by tan x. So in this case, if you substitute the value for x is equal to pi by 2, if you substitute the value for x is equal to pi by 2 minus pi by 2 is equal to 0, and log 0 is equal to minus infinity divided by, if we put x is equal to 0 in denominator, tan 0 is equal to infinity. So this is in the form of infinity by infinity by L'Hospital's rule. By L'Hospital's rule. Okay, you have to differentiate numerator and denominator separately. Limit x tends to pi by 2. What is differentiation of logarithm of x minus pi by 2? Differentiation of logarithm of x minus pi by 2 is 1 divided by x minus pi by 2 into differentiation of x is 1 divided by differentiation of denominator tan x is sec square x, that is sec square x. So still it is in the form of, if you put this x is equal to pi by 2 and this x is equal to pi by 2. So what we get here, 1 divided by pi by 2 minus pi by 2 is equal to 1 by 0, and 1 by 0 is infinity divided by sec 90. Sec 90 is equal to cos 90 is 0, then sec 90 is infinity, so this is also infinity. So now here if you transpose this 1 divided by x minus pi by 2 in denominator and this sec square x in numerator, what we guessed, this is equal to limit x tends to pi by 2. If you transpose 1 divided by x minus pi by 2 in denominator, you will get only x minus pi by 2 in denominator, and transpose sec square x in numerator, you will get cos square x. That is 1 by sec square x is equal to cos square x, and 1 divided by x minus pi by 2 as it is. Now if you put x is equal to pi by 2 here and x is equal to pi by 2 here, what you will get, cos 90 is 0 divided by, this is 0, pi by 2 minus pi by 2 is also 0. Then by using L'Hospital's rule, limit x tends to pi by 2, x tends to pi by 2. What is differentiation of this cos square x? Differentiation of cos square x is 2 cos x into differentiation of cos x is minus sin x divided by, what is differentiation of x minus pi by 2? Differentiation of x minus pi by 2 is 1 because pi by 2 is constant, and this is equal to limit x tends to 0, sorry, limit x tends to pi by 2 minus this sin 2 sin x into cos x, we can write it as sin 2x, sin 2x, and now put x is equal to pi by 2. If you put x is equal to pi by 2, 2 get cancels, we get minus sin 180 means sin pi. And what is sin pi? Sin pi is equal to 0. Evaluate limit x tends to 0, logarithm of sin x to the base x. So now first, by using property of logarithm, you can also write it as limit x tends to 0 by using property log a to the base b, we can also write it as logarithm of a divided by logarithm of b. Similarly, here we can write it as logarithm of sin x divided by logarithm of x. And if you put x is equal to 0, it will be in the form of infinity by infinity form. So by using L'Hospital's rule, limit x tends to 0. What is differentiation of log sin x? Differentiation of log sin x is 1 divided by sin x into differentiation of sin x is cos x divided by differentiation of denominator log x is 1 divided by x. So this is equal to limit x tends to 0. This is cos x divided by sin x, and cos x by sin x is cot x. Okay, transpose this 1 by x in numerator, you will get x. And now this cot x, we can also write it as limit x tends to 0, x divided by this tan x, because cot x we can write it as 1 by tan x, and this is a standard limit, and this is equal to 1. Evaluate limit log sin 2x, limit log sin 2x divided by log sin x as x tends to 0. Okay, in this case, if you put this x is equal to 0, you will get log sin 0. And sin 0 is 0 means log 0. Log 0 is infinity, minus infinity divided by, this is also minus infinity. If you put x is equal to 0, you will get sin 0, and log 0 is equal to minus infinity. So we can use L'Hospital's rule. By using L'Hospital's rule, limit x tends to 0. What is differentiation of log sin 2x? Differentiation of log sin 2x is 1 divided by sin 2x into differentiation of sin 2x is cos 2x into differentiation of 2x is 2 divided by. Similarly, what is differentiation of denominator term log sin x? That is 1 divided by sin x into differentiation of sin x is cos x. So this is equal to limit x tends to 0. What is cos 2x divided by sin 2x? Cos 2x divided by sin 2x is cot 2x, and write down this 2 as it is, divided by denominator 1 by sin x into cos x, we can write it as cot x. If you put x is equal to 0 here and here, again you will get this is infinity by infinity form. So now I will make an adjustment. Transpose this cot x, denominator cot x in numerator, and this cot 2x in denominator. What you will get? That is limit x tends to 0, 2 as it is. If you transpose denominator cot x in numerator, you will get that is tan x, divided by transpose cot 2x in denominator, you will get tan 2x. And now if you put x is equal to 0 and this 2x is equal to 0, you will get 0 divided by 0 form. Now by using L'Hospital's rule, limit x tends to 0, 2 into, what is differentiation of tan x? Differentiation of tan x is sec square x, divided by differentiation of denominator tan 2x is sec square 2x into differentiation of 2x is 2, where this 2 and 2 get cancels. Now put x is equal to 0. If you put x is equal to 0, you will get sec 0 divided by sec 0, and sec 0 is equal to 1. So that is 1 divided by 1, and 1 by 1 is equal to 1. Since I will write sec 0 is equal to 1. Next example, evaluate limit x tends to a, logarithm of x minus a, logarithm of x minus a divided by logarithm of e raised to x minus e raised to a, e raised to x minus e raised to a. So in this case, if you substitute the value for x is equal to a, you will get log a minus a, means log 0, and log 0 is equal to minus infinity. Similarly, in denominator also you will get minus infinity. So this is infinity by infinity form. So by using L'Hospital's rule, that is limit x tends to 0. What is differentiation of logarithm of x minus a? That is 1 divided by x minus a, divided by, what is differentiation of denominator log e raised to x minus e raised to a? 1 divided by e raised to x minus e raised to a into differentiation of e raised to x minus e raised to a is e raised to x. If you put again x is equal to a here, if you put x is equal to a, 1 by a minus a 0, again it is in the form of infinity by infinity. Again it is in the form of infinity by infinity. So what I will do, I will transpose this 1 divided by x minus a in denominator. What you will get? That is only x minus a. Transpose this 1 divided by e raised to x minus e raised to a in numerator, you will get that is e raised to x minus e raised to a, and in denominator this e raised to x as it is, that is e raised to x as it is. So this is limit x tends to a. Now if you put the value for this x is equal to a, what you will get? E raised to a minus e raised to a is 0, divided by, if you put this x is equal to a, what you will get? A minus a is equal to 0, 0 in any term is 0, means it will be in the form of 0 by 0. Now by using L'Hospital's rule, limit x tends to a, limit x tends to a. What is differentiation of e raised to x minus e raised to a? Differentiation of e raised to x minus e raised to a is e raised to x. Because e raised to a is constant, its differentiation is 0. In denominator, you have to apply product rule. First, e raised to x as it is. What is differentiation of x minus a? Differentiation of x minus a is 1 plus second term x minus a as it is. And what is differentiation of e raised to x? Differentiation of e raised to x is e raised to x. So here I will take e raised to x common in denominator. So numerator e raised to x as it is. In denominator you can take this e raised to x and this e raised to x common. If you take e raised to x common in denominator, we are left with 1 plus x minus a, where this e raised to x and e raised to x get cancels. Then we get that is equal to limit x tends to a. The remaining term is 1 divided by 1 plus x minus a. Now put the value of this x is equal to a. This a minus a is equal to 0. So we are left with 1 divided by 1, and 1 by 1 is equal to 1. Now you try the following limits. Try yourself. Evaluate the following limits. Evaluate the following limits. First example. Limit x tends to pi by 2. Limit x tends to pi by 2. Tan x divided by tan 3x. Tan x divided by tan 3x. And its answer is 3. Next, second example. Limit x tends to 0. Limit x tends to 0. Log tan 2x. Log tan 2x to the base tan x. To the base tan x. You can use logarithmic property and simplify. And its answer is 1. Next example. Limit x tends to 0. Cosec x divided by log x. Cosec x divided by log x. And its answer is minus infinity. Next example. Limit x tends to 0. Logarithm of tan x to the base x. Logarithm of tan x to the base x. And its answer is 1. So please try these examples.